Next up, we're going to talk about cube roots. So here we go. We're going to talk about the domain of a cubed root. Okay, one more time. Domain deals with which values, x or y? Yeah, oh, thank you. All the x values that work for the function. That's what we're looking at. We're looking at all the x values that work. And I'm just going to let you know right now, the domain for any cubed root function is always all real numbers. Or you can write it, just like the book does, from negative infinity to positive infinity. Always. 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 Okay. You want to find it? You want to try some? Want to do an example? Yeah, please. Yes, it's only this row. Oh, thanks. H of x is equal to the cube root of x minus 3 plus 2. What is the domain going to be? All real numbers. You don't have to think. Okay. Now, if you want to see something really cool, we know that it says from negative infinity to positive infinity, yes? I'm going to show you something stupid. Are you ready? You see that 3 right there on the cube root? Yes? Now what you're going to do is you're going to lay it on its side. Wait. And then you're going to make an infinity symbol. That's kind of beautiful. This is not a porn series. Sorry. Okay. So what we got is infinity. So when you see 3, put it on its side and you got infinity. Only with 3? Only, well, for now. We're only going to be dealing with cube roots in this class. But what happens if the roots are higher? That's another story. Hang on. Let's just do cube roots first. I will deal with your answer in a second. All right, what if I give you g of x is equal to the cube root of x minus 1? All right, what is my domain on this guy? All real numbers. Do you need more examples? Yes or no? No. All right, we'll do one more. We'll always say yes. F of x is equal to negative 2 times the cube root of 4 minus x plus 5. Oh, I will move it up. What's my domain? All real numbers. As soon as you see the 3 rhymes with infinity. No? Does it work? No? Let's try. Okay, so that's your domain when, just looking at a cube root function, you can just look at it and go, oh, it's all reals. We're not graphing just yet. Now we're going to talk about the range of the cube root of x. And the range, one more time, is all the y values that work for the function. All right, and the range is, you'll never guess, all reals. Or you can write negative infinity to positive infinity like the book does. So it's nice to know that the 3 remains consistent when you put it on its side again. All right? So let's look at it. F of x is equal to the cube root of x plus 2. My range is going to be it's very boring. Okay, but that's just the way this function works. If I give you g of x is equal to negative 3 plus 2 times the cube root of 1 minus x, I don't know. Let's make it up. What is my range going to be? All real numbers. Still the same. If I can use any x, kind of cool, I can use any y.
Why is it like this?
I'll show you when the graph on the That was the easiest answer I can go to. F of x is equal to -4 times the cube root of x plus 5 minus 3. I don't know, still making stuff up. Ranges. All reals or negative infinity to positive infinity. Everybody good so far? All right, can I move this piece? Oh no, it's okay. All right. Now comes the graphing time. All right, so let's do a definition of the cube root. Okay, let's talk about the cubed root graph. Okay. One more time. It is a curved graph, not a straight line. It is an S-shaped curve, so to speak. All right. And I use that loosely, as the S will be loosely done as well. Okay. But it is like an S-shaped graph. Okay. What I was telling somebody earlier was, and you don't have to write this down, this is just for show. Take a look at the number 3. Okay. Now, because I'm dyslexic, here's what happens in my head. I do this. Okay. This is me with dyslexia. Okay. And then, since I made an S, your graph is, like I said, loosely based on this, right? So what I'm going to do is pretend that there's a really strong wind on this, and it kind of looks something like this. Ish. Okay, I say ish. Ish. Looks like that ish. Very good. Okay, so the 3 becomes a little backwards and then flails in the wind a little bit. Now, why was the question? Why is it all real numbers and stuff like that? Now, go back to, let's do a review example, okay, on cube roots. If I have the cube root of 8, right, 8 is made up of 2 times 2 times 2, right? So our answer is 2. So I can have a positive underneath, correct? But if I do the same example, but I make it a -8, remember, under cube roots, I can have negatives, right? And because of that, the cube root of -8 is -2. So I can have positive and negative numbers in it, which means I can put any positive in there and kick out a positive. Any number, negative number, I can kick out a negative, which is why I can go from negative infinity to positive infinity. All right? And when we start graphing it, we'll see, I was like, oh, yeah, that totally makes sense now. But that's just a little review for the intro as to why. So, again, there's my dyslexia at its finest. There's your review. Let's do an example here. Let's graph some cubed roots. Start out with the basic, I guess. We're going to graph f of x is the cube root of x. Now, it will feel the same a little bit, but it is different because this is a different graph. All right, there is no start and stop, okay? So step 1 will feel the same. Set the radicand equal to 0 and solve for the variable. And we're going to do the work right now. So you see how it's very similar as far as, step 1, yes? So we're going to take our radicand, the inside, set it equal to 0. And voila, I know it's really boring, but we just wanted a basic example. And this is no longer a starting point. This is, for all intents and purposes, this is the middle of our graph, which means that this will be the middle of our chart when we make it, okay? So the reason why there is no middle officially is because it does go from negative infinity to positive infinity. So in that case, it has no middle, but for us, this is where it becomes unique in the inside, and we want to see this lovely little bend in there, that S curve in there, all right? So step 2, we're going to do our chart, all right? We're going to set it up like we did before. And I made it a little bit too long, but that's okay. And that's the cube root of x. Now, because we have a middle, this is where my 0 is going to go. So whatever you did for step 1 will go into the chart in step 2, but it'll be the middle of our chart. So I want 2 numbers above and below. The reason for that is if I do 1 number above and below, it will look like a straight line, which it's not. Okay, so I want 2 above and 2 below 0. And I'm going to move it up here in a second. Everybody with me? Mm-hmm. So one more time. What we want are numbers that are going to add up to a certain cubes. Okay? What is 1 cubed? What is 2 cubed? 8. 8. All right, so 0 cubed is 0. We have 1 cubed is 1. 2 cubed is 8. These are the numbers that we're going to be building. All right. What is 3 cubed? 27. Now remember, this is just one direction that we're going. We need to go in the opposite direction, so we're going to have to use negatives. Okay. So instead of 1, what if we use -1? What's -1 cubed? -1. All right. And if we do that, what's another number that I can cube? What is -2 cubed? -8, and then -3 cubed is -27. More than likely, you're going to be building those inner 5 right there, not necessarily the 27. Will it happen? Yeah, it could happen. But normally, we just build from -8 to 8. Okay? Everybody with me so far? So the same idea that we did in square roots for finding that, we want to come out perfect applies to cube roots too. Okay, so the same idea all together again. Now, what number, when I cube it there? So what number do I want to choose for x? 1 and -1, what's another number that I can choose? 8 and -8. Because again, all this is a cube root, there's nothing like a +2 or a -5 or something like that. So just a basic cube root will work. So we're going to take the cube root of 8. And in case you forgot, 8 is 2 times 2 times 2. Do I have 3 of a kind? Yep, my answer is 2. Right? So this gives me the point -8, 2 on the graph. Yes?
So what was the particular reason you used 8? Because I'm still not grasping this. So I'm
8
grasping
is-
like how everything's done. I just don't know why you choose the 8. So I understand the -1 and the 1.
First off, I wrote 8 and this should be -8. Hang on one second. So this should be a -2 and a -2 and a -2. So FYI, wasn't paying attention. I thought that was a +8 up on top. These are all -2. So your answer should be. Now, the reason I chose 8 is made up of 3 of a kind. It's 2 times 2 times 2.
And that's the only reason why?
It's the only reason why. I want 3 of a kind. I want it to pop out perfectly. 3 of a kind, index is 3, boom, nothing left underneath the radical.
All right, I was definitely thinking. Cool.
Okay. All right, if we do -1, let's see if we can do the right one this time. The cube root of -1 means that I've got, what, -1 times -1 times -1. That still multiplies to give me a -1, correct?
Mm-hmm.
Final answer will be -1. All right, then we got the cube root of 0. I think we go straight to the final answer, which is 0. Cube root of 1 is going to be 1. Same idea as above with negatives. The cube root of 8, 2. Yep, number 8 is made up of 2 times 4, 4 is 2 times 2. I have 3 of a kind. I pull out a 2, nothing's left. Josie?
Should we always, like how we did it a couple sections ago, you know how, see how it follows a pattern?
Yes.
Should it always follow?
It should always follow, should always add or subtract 2, -8, -1, 0, 1, or 8, always. Just like we did 0, 1, 4, 9, 16. That's what we want. Now, all those numbers on the board are what we want
So
them
say
to
that we
build
get-
to.
Like on the last one right there, say we just get like the number 4, whatever, for whatever reason.
If you got a 4, then you know that you're wrong because it should add up to any one of those, whatever, that's 7 on the board. Okay? So, yeah, be very careful. All right, let's actually sketch this graph. Okay, so those are my numbers. My X's, these graphs now get a little bigger because of the fact that I gotta use a lot of numbers and I stretched out the X's. So, my Y's are not gonna be that big, which is nice. So I got 2, 1, there's my 0, -1 and -2. I'm just gonna go out and just do single tick, so 1, 2, 3, 4, 5, 6, 7, 8. So my x-axis. -1, 2, 3, 4, 5, 6, 7, 8. Everybody with me so far? All right. So here we go. I have the points -8, -2. Gonna kind of make that work. I have -1, -1, 0, 0. Always plot your points first. That way you can see if you can really tell if you did it wrong. Then I have 1, 1, and then I have 8, 2. And if you were to connect the dots, you notice there's an S in there, right? That looks like it's been hit by the wind. Do you guys see it? If you've got a dot somewhere, like let's put another dot here. It does not follow this lovely little curvaceous little pattern here, right? Now, whatever you do not, let me go back to the board again, right? Please, 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 a lot of calculus students again, do not do this. That's a straight line. This is not a straight line, all right? We only did whole numbers because they pop out nice and easy. This is kind of like the square root function, but 2 of them. All right, you've got this lovely part in here that's curvy, all right? And then you've also got this lovely part in here that also curves. So there's this little curvy thing in there. So that's where really the S is at, okay? Do not make it a straight line. My calculus students love to just give me segments. Don't do that, okay? Don't go and. That's not a line, that's a segmented line. That's gonna drive me insane and any other teacher insane. Everybody good? All right, so let's do the curve, the sexy curve on this. All right, so we've got a little bump out right there. Okay, make it sexy. Okay, curvilicious right here. Okay, curves out a little bit there. All right, and again, you're gonna have arrowheads now on both ends, so please remember the arrowheads because it does go on forever. I'll move this up so you can see it. And while we're here, let's talk about it. What's my domain? All real numbers. Yeah, if you were to stretch it out, right? It's going from -infinity to +infinity. So my domain is all real numbers. Stretch it out like Superman, okay? It's just like just like this guy right here, right? You can kind of see the S-shaped curves in it, all right? But if you want to stretch it out, right, it would go from -infinity to +infinity. Pretend it's a straight line, okay? And what is my range? Well, if you were to take this graph, which is really this graph here, this is never gonna, there it is, and you were to actually stretch it out in the Y direction, you would get a straight line for the range. So what's my range? All real numbers. Again, you can write it as -infinity to +infinity if you want to follow the book, or you can use the other notation. How'd that go? Does this explain why we have the graph we do? Okay, any questions on this? Yes or no? Okay. All right, you wanna try another one? Yes, of course, all right. Let's do another one, we'll sneak that in there. Yes.
Is this still 17.9?
Yes, it's still 17.1B. It takes forever, right? If you really want to do it right. All right, what if I give you u of x is equal to the negative cube root of x plus 2? Do you want something inside besides x? It is kind of boring.
Yeah.
Can I go like a -3 in here? Is everybody okay with that? All right, now, one more time, notice that there's a lot of junk in the function, right? That means that we got a lot of work going on, right? So we're gonna need a lot of room between the x and the y in our chart. So let's figure this out first. Step 1, set your inside of the radicand equal to 0. So x minus 3 equals 0 means that x equals 3. All right, one more time. This is now the middle of the graph, which is the middle of our chart, right? So that's step 2. And we're gonna have x. I'm gonna make this really, really, really long because there's a lot of stuff going on. I have the negative cube root of x minus 3 plus 2. I have to make 5 lines. 1, 2, 3, 4, 5. All right. X minus 3 means that it's going to be the middle of my chart. All right. Do you want to pick numbers right now, or do you just want to work this problem out for x? Do you want to find the other values of x while we're here?
Yes.
Okay. So, what number minus 3? Now, because you set it equal to 0, you actually found the 0 part, right? We made the cube root of 0. So, what number minus 3 equals 1?
2.
That'll give me -1. I'm cool with 2 then. All right. If I choose 2, 2 minus 3 will give me a -1. So that gives me this guy right here. Does everybody see that? All right. So what number minus 3 will give me one of these numbers in here? 4. 4 minus 3 will give me a 1. Since 2 gave me a -1 and 3 is 0, I'm going to put 4 here. Put them in order because you'll find out that your answers will be coinciding a little bit. All right. No, they won't. Not in this case because we moved it right and we're going up. All right. What's another number that I can use? So what I formed right now is -1, 0, and 1. I need to form a -8. So what minus 3 equals 8? -11 or 11? Let's do, hang on a second. 11 minus 3 will give me a +8. So I'll put 11 here. So 11's good. I can see where your brain's going. So 11 minus 3 gives me 8. -5 will give me a -8, right? -5 plus a -3. The graph is weird. The graph is dyslexic, just like I am. All right, so you found your values. Awesome. All it is now is plug and chug into every single bloody line. All right, here we go. I have the negative cube root of -5 minus 3 plus 2. All right, -5 minus 3 should give me what? A -8. Does it match one of these numbers on the board over here on the right? Yes, that is perfect. This is what we're going for. Does everybody see that? Okay. Then I have this +2 on the outside. Do that last. What now? I got a negative. What is the cube root of -8? -2 plus 2. What's a -2? So we have 2 plus 2, which gives me 4. All right, so you have the point -5, 4 for your graph. All right, gotta love keeping all this in order. Everybody likes that, right? At least I do. I'll screw you guys out of it. All right. Now we got the negative cube root of 2 minus 3 plus the 2 on the outside. Remember, always do the inside of the radical first. You gotta do the parentheses, right? So we have the negative cube root of -1. Again, -1 is one of these answers on the board over here, right? That's what we made. Awesome. What is the cube root of -1? Yes, Ms. Hanley, it's a -1. Great. All right, negative cube root of 3 minus 3 plus 2. We get 0. And notice that we're actually following everything we're doing on the board. -8, -1, 0, 1, right? And 8. -8, -1, 0. That's what we're following. It's perfect. All right, got the negative of 0 plus 2. So we just got 0 plus 2, which is 2. Right? Notice we're having some loveliness happen over here on the y's. That's beautiful. Let's see what happens when we plug in 4. All right. We have 4 minus 3 plus 2. So we have the negative cube root of 1 plus 2. Now, when I pop out the 1, the cube root of 1 is 1, right?
Mhm.
So I have -1 plus 2, which gives me 1. Are you seeing a pattern when you put it in right for your x's? I bet you I know what the next y value is going to be without having to do any work.
Yeah.
Oh, and she put it. You think it's 0? We think it's 0, right? Why not? Let's try it. All right, you got 11 minus 3 plus 2. So that gives you the negative cube root of 8 plus 2. And 2's on the outside. Got the negative of 2 plus 2. So negative 2 plus 2 is 0. By putting it in order, right, from small to large for your x's, you will get a lovely pattern for your y. All right, let's graph this. Yay, so excited. I can feel it. All right, any questions on what we did so far on that table? No, I make it look easy?
Yeah.
It's a lot of work? Yes, that's a lot of work. All right, so we're gonna be using all these bad boys to graph. My x's go from negative to positive, my y's are only positive, so I'm only gonna do the top half of this guy. I'm gonna move it over a little because my x's only go to -5. My y's go to 4. Let's see, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's my x-axis, that's my y. I'll zoom out a touch. And again, just plot your points first to make sure that you did not screw up. All right. So we have -5, +4. We have 2, 3. We have 3, 2. 4, 1. And then we have 11, 0. It's kind of flowing. Do you feel the S curve in this one? Yes? Doesn't look like there's any out of place, not something weird, like out in Sissy La La Land somewhere. All right, so this is the middle of the graph, right? We said 3, 2 was the middle of the graph. So this is where our sexy curve comes into play. And there's another sexiness over here. Alright, nice and smooth. Like butter, right there, like butter. Alright, and if you want to label it, you can call this U of X, since that's what we did. Alright, but you don't have to. Alright, what's the domain of this graph? All real numbers, just stretch it out so it goes straight. Alright, and then, because I'm injured, what's my range? All real numbers, exactly. So domain is all reals, my range is all real numbers. Right, again, this is what the book will do, no biggie. Right. Do you want more?
Well, it needs to be even did pretty good. Otherwise, my notes are.
Seriously?
Yes.
Seriously, you want it even.
Are you doing 3 graphs for the square root? I'll do 3 graphs for
I do have one more thing in this section for 17.1B. Aside from graphing, I'm sorry, you're gonna have to have it uneven, so your teeter-totter will be a little unsteady. So, poor thing. We're going to do a lovely rule. This is the last thing that we gotta do in 17.1B. So the drafting's done, which is nice. So, little add-ons here. All right, we have this rule for radicals, and it is the nth root of x to the n equals x. Okay, this is a really cool rule. All right, notice that the index matches the power on the inside, right? You guys see that? I zoomed out a little. Let's zoom back in. All right. The index is the same as the power on the inside, all right? Now, let's talk about this. Where x belongs to the set of real numbers, all right? So that's one thing, x belongs to a set of reals. And let's talk about this. Where n is an odd, positive, real number, okay? So we're discussing right now the odds of this one, okay? So n is odd, the powers on the index are odd, x can be anything it wants to be. Has everybody got me? Okay, so, and it's really, really neat. Now notice it just equals whatever that thing is, okay? Let's start out very, very basic. We're just gonna simplify. That's all we're going to do. Our first example, if I give you the 7th root of c to the 7.
Cross out the 7, take out the C.
By crossing out the 7s, you also cross out the radicals, right? And so, boom, that goes away, right? Now, we are just gonna get c. But if you remember from before, if you really don't like that, let's do the same example. All right, I got the 7th root of c to the 7. Remember what we said on the last lecture? We said that we can write this as an exponential, right? Any outie, belly button theory, right? Any, the inside one is 7, the outside one is 7. What's 7 over 7?
1.
1. So this is c to the 1 or just c. And that's the reason why it works. It's beautiful. Everybody's cool with that? All right. If I give you the, let's see if you guys remember this, the 5th root of p to the 5th r to the 15. All right, now we're kind of not dealing with the x to the n, n to the n over n, excuse me. But this is reminiscent of what we did last time. Are they all divisible by 5?
Absolutely.
Yeah. So, what is 5 divided by 5? 1. What is 15 divided by 5?
3.
3. So you can write this as like that, or you can just write it as PR cubed. So that's just a lovely little what if scenario. All right. Let's do some polynomials real quick. What if I give you the cube root of y minus 2 cubed? Right, notice that your index matches your power. So we'll cross out the index, the radical, and the power, leaving us with y minus 2. We all right? Okay. Now that would be nice if that was that easy. Next step, hang on a second before we go. What if, oh, this is interesting. I give you the 7th root, and don't be afraid, please don't be afraid. 128 times 2 plus 3x to the 7th power. There is only one number that gets to 128 when you multiply it. Now, notice 128 is even, yes? There's only one number that when you multiply it 7 times gives you this, and honest to God, low number of 128.
7 times 2 is 14, 14 is 28, so it would be 2.
I did not understand that logic.
What, is it 2 now?
It is 2.
Okay, so
But I'm not sure about your logic, but if that gets you through it, I'm
Well, my
really
logic
excited.
is, okay,
No, I don't repeat it, do not repeat it. All I know is that this is 2 times 2 times 2 times 2 times 2 times 2 times 2. And that will give me 128. So it is an even. Something to the 7th power normally will get really huge really fast. And the only one that gives us this number, which is small, okay, has to be the number 2. So this is the 7th root. If you want to see it, 2 to the 7th, 2 plus 3x to the 7th. Your logic escapes me, but it's interesting at the same time. So just an FYI. But if it works. All right, so tell me what my final answer is, y'all.
Bless you, bless you. Thank you.
2 times 2 plus 3x, right? Remember, if it's times on the inside, it is times on the outside. Do you have to distribute the 2? No, leave it. Oh, everybody cool. Don't want a George, so this is cool. Let's do a few more. Just to make sure we
right now?
Wow, you really want to do that?
I was
Trying to help you out.
Yeah. Let's do this one really quick. Let's do at least something with a negative on it. And then we're officially done with this. I have the 5th root of negative 32. Now, remember me in your head when I said a small number to give me just a 128. And this is still a small number to the 5th power. So what do you think this is? And it's even. 2. So what we have here is the 5th root of negative 2 to the 5th. Okay, do I have to write it like that? Yes, I do. Okay. Negative 2 times negative 2 times negative 2 times however many is dot, negative 2, right? Final answer is negative 2. Awesome. The end. It was happily ever after.